Hey everybody, this video lesson is going to cover predicting products for single displacement reactions. If you remember from my little video lesson on how to identify types of reactions, single displacement reactions start with a individual atom, usually a metal, and an aqueous solution. And A is going to try and replace B. Now if A replaces B, B is now by itself, and A is now with C. Now up until this point, the three other types of reactions that we talked about so far, synthesis, decomposition, and combustion, we assume always happen. If you want it to happen, it's going to happen. But single displacement, along with the next one, double displacement, may or may not happen. And it's your job as a chemist to decide, when given the reactants, whether or not the reaction will even happen at all. And you can actually check this before you even begin writing out anything for the products. And I'll show you how to use that particular skill here today. The focus of a single displacement reaction are on two things, the metal and the cation. The metal and the cation are in a competition. The metal will replace the cation only if it's more reactive than the cation. So A, the metal, will replace B only if A is more reactive than B on the activity series. So you're looking at the metal compared to the cation. Now the activity series, as I pasted a picture here, is a thing that you will always be given, and it's used only for the single displacement reactions. And it's a list of metals and also hydrogen in order from most reactive to least reactive. So in other words, if the metal is above the cation on the activity series, the reaction will happen. A will replace something below it, B, as a cation. Now if the opposite is true, if A is lower on the list and B is higher on the list, then this reaction will not happen. I like to think of this as kind of like water flowing downhill. A metal will replace something below it, but not backwards. Just like water always flows downhill, metals always replace downhill. A metal will replace something underneath it. So here I've listed a handful of single displacement reactions. And I don't know whether or not they're going to react because I haven't checked the activity series, but I've posted a copy of the activity series on the right-hand side. And so the first thing you do is determine whether or not the reaction will happen at all. Step 1, and this is clearly much more complicated than the previous predicting products types, so pay close attention, but you need to determine if the reaction will happen or not. So you take a look and you find the metal and the metal cation. Now the first one, aluminum's here and lead is down here. So this reaction will happen. And so I'm going to put this on the back burner. I'm just going to quickly say, yeah, this reaction will happen. I'm going to check the next one, and I'm just going to look for the ones that are no reactions. And so my next one, potassium with iron. So I find potassium, which is pretty high up on the list. Iron is pretty low on the list, down here, kind of in the middle. So this reaction, again, will happen. Finally, sodium. I'm going to find sodium, which is about 4 down, and lithium. Now, since sodium is trying to replace lithium, it will not because lithium is higher. So this reaction is a no reaction. So you can put NR as a predicting product because there is no product. NR, or no reaction, means this reaction will not proceed. So now that you've determined whether or not the reactions happen, the first two indeed do happen and the last one doesn't, we then do step 2, replace the cation with the metal. So I'm going to come in and I'm going to kick out lead. So lead's by itself, and now aluminum is going to be with chlorine. And for this next one, I'm going to kick out iron. So iron's by itself, and potassium is with oxygen. The last two things I always do is check for diatomics and then balance charges. Now diatomic would only happen if the cation is hydrogen over here and gets replaced. Notice, hydrogen's on the list. It's between lead and copper. So if this ionic substance is maybe an acid like HCl or HBr or some sort of acid where you have HCl, then the aluminum would replace the acid, H, and then this substance right here, this thing that's alone or that got replaced, is hydrogen, and that's diatomic. So check diatomics, in this case only for hydrogen. Now the other thing that you need to do is you balance the charges. So look at your new aqueous solution, AlCl and KO, and you need to make sure that those charges balance. And so aluminum is a +3 and chlorine's a -1, so I need AlCl3, and then I go in and erase the charges, and then K is a +1 and oxygen's a -2, and it's K2O, and then I go in and erase the charges. So in summary, it's important first to determine if the reaction even will happen or not, and that's the thing you do very first step. If you've decided it does happen, replace the cation with the metal, and then check for diatomics and balance charges. Now this is clearly much more complex than anything you've done up until this point, but hopefully this video lesson was helpful. Thanks for listening.